Hello, everyone. So Seabee is yet another workflow processing engine that also supports BPMN. So you might have seen a glimpse of Seabee yesterday when Daniel introduced the Camunda Cloud. And today, in a previous session, Arthun Subashi also showcased Seabee, and he showed how he used it to integrate it with the serverless FN project. So Seabee is a horizontally scalable distributed workflow engine, and that's what makes it different from others. So why do you need to scale a workflow engine, right? So there are many new workflow automation use cases that coming up that needs to process not just hundreds of workflows, but hundreds of thousands of workflows per second. So this opens up the question, can the existing tools really handle load in such a large scale? So let's say, so this is a typical architecture of a traditional workflow engine. So you have a central database, and you have a workflow engine that stores all the state needed to process a workflow. So it stores all the state into the central database. And if you need to scale, if you want to process more stuff, what you do typically is add more of workflow, more engines there. So you can do more, or you can process more things in parallel. But all of the engines write to the same central database. So at some point, this central database becomes a bottleneck, and you cannot scale anymore. And that's why we need to rethink the entire architecture. So Seabee is as I said, it's a horizontally scalable workflow engine. It's designed from bottom up based on well-known principles of distributed systems. So it's specifically designed to be horizontally scalable and fault tolerant, and to handle large workflow automation requirements. So the core of the Seabee is the Seabee cluster. So it can consist of one or more brokers. So the broker is the one that is actually doing the workflow processing. So it can have more than one broker. And there's also this gateway. The cluster can have one or more gateways. The gateway receives requests from the clients and then distributes it among the brokers. So I'm going to zoom in here and discuss these three main concepts, event log, partitions, and replications that make Seabee scalable and fault tolerant. OK. So first of all, there is no central database in Seabee. Instead, all the changes to a workflow is written into this event log. So the workflow processor writes to the event log. So the event log is like a sequence of events. The processor reads the event from the log, processes it, and then appends it back to this event log. So for example, let's see what happens when a client want to create a workflow instance. So assume it wants to create this very simple workflow. So for what the client does is it first sends a command, like create workflow instance, and that event is first returned to this event log. And then we have a workflow processor that is reading events from this log. So it first reads that command, process it, and see all the checks that, OK, can I create the workflow instance now? Yes. So it creates it, and then it writes an event, OK, the workflow instance is created. And then the processor goes to the next event in the same log, and then it processes it. OK, so workflow instance is created. So what's next? So we have to create, we have to start with the start event, because that's the first thing in the workflow. OK, it then writes an event. OK, the start event is ready, and then it further processes these events, and then it reaches the service task, and then it's OK, now the service task is created. And then the client can, so if you're familiar with Camunda, it's more like an external task pattern. So the client can then activate the job. So the client sent another command, activate the task. So that is again returned to the same event log. and the workflow processor then reads that command and then say, okay, now the job, you can activate the task, and then it writes, okay, the task is activated, and then it sends the response back to the client. So there are many, so like you see here, the changes, the workflow processing is captured as a series of events. So the state changes, you can see it from the event. So the events that I showed here are like just an abstraction. So in Seabee, really that the events are more fine-grained, and there are more steps actually happening here. If you're interested, you can go here and to see exactly what's happening inside. But you just get the idea. This is what's happening. So there are several advantages having such an event log. So for example, if the system crashes and restart, you can just rebuild the state by going through all the events. So you don't have to worry about like partially written transactions or partial commits or anything. So, but what I want to focus here is that because all the events are totally ordered and there's a processor processing this sequentially, you can easily handle concurrent events. So for example, assume there are two clients trying to activate the job at the same time. So they send the command together at the same time, but one of the command is written to the event log first, and then the second command is written. So the workflow processor is here now. So it first reads the first command and then processes it, and it say, okay, there is one job available, so you can then activate the task. And then it goes to the next command, and then it processes it, and it sees that the task is already activated, and then there is no new task. So yeah, then it say, okay, no task available, please try later. So see, it's because all the commands and events are already totally ordered in the event log, so you have like a deterministic order in which these things are processed. So you don't need to kind of lock the database or use any other synchronization things to handle these concurrent operations. So to kind of sum up, so you have a workflow processor, and which is writing events to this event log, and you have like there is one processor like sequentially processing it. So now, what would you do if you want to scale this? Of course, add more of these things, yeah? So that's what we call partition here. So in Seabee, a partition consists of one event log and one processor that is processing the events from that log. And you can have more than one partition in a cluster, and if you have more than one broker, this partition will be distributed among the brokers. So for example, here, let's assume you have two brokers, and then two partition can be in one broker, and the other one is in another broker. Now, if assume a client is sending another command to create a workflow, so when the gateway, when receive the command, it picks one of the partition and then forward the request to that partition. So that workflow will be created in that particular partition, and all the state needed to process that workflow will be handled by that partition for the rest of its life. So the main thing is that there is no data shared among the partitions. So if you need to process a workflow, you don't have to talk to others. So you can just do progress independently. So that so you don't need to communicate with or synchronize. You don't have to synchronize or anything. So what does that give you? If you add more partitions, you can do more things in parallel. And so this is what we expect. When we add more partitions, you can scale the throughput. Yeah, and let's see if that is the case. So we did do some evaluations. So we want to measure the horizontal scalability of Seabee. So what we did is to measure the number of workflow instances created per second. So we first started with one broker with 8 partitions, and then we added more brokers. So and so you can see that, so here is with the one partition, one broker with 8 partition, and here you have, I think was 24 brokers with, so it's multiplied by 8 number of partitions. So you can see that you can kind of almost linearly scale with the number of with the number of partitions. So that's what the kind of scalability that we expect from Seabee. Now we talk about the event log and the scalability. And the next thing, so when we talk about this large-scale system, especially when we talk about cloud and other stuff, is fault tolerance. Like what will we do if something fails? And it can fail, right? So I think from yesterday in one talk, it was kind of saying like there are many cases where the hardware can go wrong, and then so we have to take care of these things like what should happen when something went wrong. And in Seabee, we does that by replicating the partition. So each partition can have more than one replica, and then each replica is managed by different brokers. And then so we use an algorithm called Raft. It's a well-known algorithm for this kind of replication and distributed consensus. So the main idea here is that you have one leader which writes the events to the log. So in our case, it's also doing the workflow processing. And then you have the followers, which is just replicating the events. So the event is considered successfully replicated if it's returned to the majority of the majority of the replicas. So and now if let's say the leader crashes. So now the leader is doing the workflow processing, and then suddenly the machine crashes, for example. And what will happen is that one of the follower becomes the leader, and it continues processing from the point where the leader where the leader stopped. Yeah. So here. So we don't have any central component that decides who is the leader or anything. So we, again, use the Raft protocol, and the replicas kind of talk to each other, and then they decide. So it's like a democratic election, and they choose who's the leader, and then it can continue processing. So typically, it's so if there are majority of the replicas are available, you can make progress. So if you have 3 replicas, you can tolerate up to 1 failure, or like if you have 5 replicas, you can tolerate up to 2 failures like that. So of course, if you have more replicas, it's better in terms of fault tolerance, but of course, you have the overhead of doing replication to more number of machines. Yeah. Okay. So now we have learned a little bit about what are the components of Seabee cluster. So if you want to start a Seabee or set up a Seabee cluster, you have the main 3 things that you have to think about is these 3 factors. So one is the cluster size. So the cluster size means the number of brokers you have in the cluster, and the partition count. So the number of partitions in the cluster. So as I said, like more number of partitions, you can do more things in parallel, so it's better the throughput. And the replication factor says like how many replicas you need for each of the partition. So replication factor affects the fault tolerance, and number of partitions affects the scalability or the throughput of the cluster. Okay, so let's see something in action. So I'm going to a demo fault tolerance of Seabee. So I use this setup. So I have a Seabee cluster with 3 brokers and 1 gateway. And I also set up a Prometheus and Grafana server to monitor Seabee and what is happening inside. And so I just have like a small client app which kind of generates some workload to the Seabee. Okay. And once everything is running, we will kill 1 broker and see what happens. Okay, so I have set up a Docker Compose for configuring everything. I will share the code later so you can have a look at it, but I'm not going to go through everything. So it's just the Docker Compose setup for the picture that I showed. Okay, so first we are going to start the Seabee. So we can do no. Okay, sorry. This is easier. Okay, so this is starting 3 CB brokers and 1 gateway. So now it's done. So I will also start Grafana and Prometheus. So you can, it's already there when we start. Okay, let's see if the CB is up. So I'm okay. So you can see that there are 3 brokers. You can see that, right? Okay. So you have 3 brokers and 2 partitions, and you can see that one of the broker is the leader for 2 partitions. Yeah. Now let's start some. Let's start a client application. So what this client application does is it create workflows in a fixed frequency, and there is also a job worker that kind of activates the task and complete them. So the client application is a Java application that just communicate with Seabee. Okay, so now it has started to do some work. Let's see that if we can see that in our Grafana. So I have so the Grafana is started, so we can log in to it, and probably, is it better? Yeah. Okay, yeah, so you can see that there is something happening. So here, let's say that the workflow instances are activated per second, and here is the jobs that are being activated and completed, and here you can see the same thing in the graph here somewhere. Maybe I'll leave it for a second so it's moving fast. Maybe I can also ready, no. Okay, it's difficult. Okay, so no. Okay, so it's doing some work. So it's creating some workflows and completing it. So it's constantly, the application is constantly talking to Zeebe. Now, I'm going to stop one of the broker. Let's see once again who's the leader. So the leader is broker 1. So the leader is the one that is actually processing all the commands from the clients. So let's. So we kill it. Let's see what happens. Okay, so we killed it. And let's see if we see something strange over here. You have to wait for some time because, yeah. You can see a small drop here because now the leader is died and it's kind of stopped processing the commands for a while. And yeah, so it takes some time for the other brokers to gossip that, oh, okay, so now there is no leader, so we have to do a new election, and then do an election, find a new leader, and the new leader starts reprocessing all the events in the logs, and that's why you can see kind of an how do you say, a peak here, because it's reprocessing all the events that the leader has already done. But reprocessing is fine because the event log is very deterministic, and you can kind of rebuild the state by just going all the events. So looks like the new leader has come up and start processing. And if you go here, you can see that the new leaders are elected. So for partition 1, it was broker 0, and for partition 2 is broker 2. So yeah. So if you want, we can also so we bring the CB1 back up because we can only tolerate 1 failure at a time. Okay, sorry. I have to start new one. Okay, So the new one is coming back up. If you can see that now there are the leaders there are two different leaders. So if we kill one of them, let's say CB2, sorry, not up, it should be stop. So this should do a re-election for partition 2. Yeah, it did immediately. It was very fast. You can see that here, the partition 1 is doing the processing with no problem. And the 2, which we killed the broker, it suddenly has a drop. So what I want to show here is that if something happens with one part of the cluster, like for one partition, you can still make progress in others without affecting. So you don't, like if there was some failure, it's not like the entire cluster is going down and you cannot make any progress. It's like it's concentrated in a small area, and you can kind of make progress in others. Okay, so yeah, it's running there. I just kill everything, and so I hope now you have, yeah. So you have. So we have now see what Seabee, like how Seabee is scaling and what are the main concepts behind Seabee. And if you are interested into trying out what I have just shown here, there is the I have published the code here in this repository there. Or if you're more interested into doing more getting started guide of Seabee, please go to the Seabee.io and go through all the documentation there. So if you have more questions, so we have a Slack and a forum to, and you can post your questions there. But I think now we have some time for questions here also.
Super. Thank you very, very much, Deepthi. Yeah, I didn't even need to ask. Your hand's already up. That was really quick. So yeah, and he's in the front row, so I'm not going back there for a while. So anyone here have a question, let me know early. Okay, there you go.
So how does the gateway scale?
So gateway is a stateless application, so you can scale gateways. So you can add more gateways, and it's fine. So it says gateway is more like routing the kind of like load balancer, but with some extra duties. But you can scale it by just adding more of this.
So like client-side load balancing or something of the gateways.
Yeah, so the gateway is still part of the Seabee cluster. So
yeah.
it's still in the cluster. So it's not running on the client side, but it's in the Seabee cluster. But you can add more gateways into the cluster, and you can just scale like that. So there is no state shared between the gateways, so there are no restrictions.
And the client just like a round robin.
Yeah. So yeah, for the client, yeah, you just have to give the address of the gateway. So if you have more gateways, you have to feed that to the client. Yes.
Cool. Thank you. Next up, okay, let's go along here then.
Yeah, hello. Thank you for the presentation. I would like to ask, how is the latest state before the crash shared with the other brokers? So the partition is somehow persisted and.
Yeah. So this event log is replicated. So it's in a consistent state. So at least the majority of the replicas have the same event log. So maybe one of them is lagging, but the other two has the same event log. And the events in the event log is such that it's deterministic. So when a new leader comes up, it can go through the events and see exactly what was the previous state of the crash leader. So it kind of do a reprocessing. But we also have some optimization on top of that, where we kind of save the snapshot, and the snapshot is also replicated. So you don't have to always go from the beginning of the log to the end.
But thank you. But where are the events saved? So they sit in one shared database or Elastic?
No. So every broker, like every partition, has its own event log. So let's say there are two brokers, which is sharing the replica for the same partition. Both of them will have this event log, and that's replicated. The event log is replicated
That's the key.
within the Seabee itself. So we don't use any external database. Everything is handled by Seabee. So it's
I didn't probably catch it. So it's replicated.
Yes, yes.
Thank you.
Okay, we'll get there. Don't worry.
So I actually have 3 questions. The first one is like, how is this related? You mentioned the event log. How is this related to Kafka? Because all that vocabulary you mentioned is very similar to what Kafka has.
Well, we have there are some common concepts in Kafka and Seabee, like it's like partitions and replication stuff. But what Seabee is actually is it's a workflow processing engine.
So it's your own custom implementation, right?
Yeah.
Okay. Okay. Second question, like how stable Zeebe is.
So we had our first production ready release 2 months ago, and yeah, I mean we are still improving it. So you are free to evaluate it and see how it's fitting your But I can say that we have our first production ready release, so which means that we think that it has the basic functions to make it work. Yeah.
Mm-hmm. Okay, and third question, is Zeebe going to replace Camunda engine?
I don't think so, because I think Camunda is good for its. I mean, it's there and many people are using it, and it's good for whatever use cases that it's fitting. Seabee, I think, is targeting a different set of use cases where you need like very high scalable, low latency applications.
Yeah, but generally, like if you say somebody like, do you want high scalability or do you want the regular Camunda engine, everybody will go to Zeebe, right?
At least for now, Seabee doesn't support all BPMN simples.
Mm-hmm. Okay.
So
Okay.
Thank you. I have simple question, but newbie question, as I didn't have a Zeebe for now. You mentioned there's a gateway, and it is somehow passing the messages to one of the brokers, but in some setups, not all of the brokers are having the same partitions. How does it actually know, for example, like if I want to correlate this message or something like that, which broker and partition to take?
yeah, so the gateway is actually part of the cluster, so it knows which broker is having which partition. So it's constantly, the information is shared among gateway and the brokers. And the gateway actually not chooses a broker, but it chooses a partition. So it kind of have a strategy to distribute the requests among the partition, and then at any point it knows who is the leader for that partition, and then it sends to that particular broker.
Okay, next up. Oh, you're right here. Yeah, next door.
Yes, if you have many brokers, how do they figure out who is the leader? Is there any algorithm, and why do they have to have a leader?
So we have an algorithm, so it's called Raft. So it's a distributed consensus algorithm, so that's widely used in many distributed applications. And so that's the Raft. This algorithm kind of handles all the replication and also the leader for that. So it can choose who's the leader, and it can do it in a consistent manner that even if some failure happens, nothing goes wrong. And you need a leader because we need to have this strict total ordered event log. So if 2 people write at the same time, you're kind of, so you need to, I mean, that's not we don't want to kind of handle the conflict and other stuff. And this is kind of a nice design that even if you have a leader, you are not kind of having a master-slave replication. You know, it's more like a master-master replication that it automatically handles if there are some failures. Yeah.
Okay, cool. I'm going to try this side of the room to see if anyone has a thing. You better, because I came all the way down here. Okay.
I was just wondering, why in this algorithm does the new leader have to process all the events of the previous leader if there is already a majority?
So that's not the part of the Raft protocol, but that's how we implemented Seabee, because this event log just have all the events that, okay, what has happened to this, all the workflows that we have processed. And then, but we need to also build like exactly what's the current state of the system. Like, okay, these workflows already processed, it's done, so you don't have to do anything more for that. So these things you have to, when a new leader comes up, it has to rebuild the state. So that's why it's kind of reprocessing. But as I said, like, you don't have to always reprocess, because we also replicate the snapshots. So you can just like start from that snapshot.
Okay. Do you have a question? Yep.
One question for understanding. So only a broker who have a leading partition proceed, and if a broker not have a leading partition, any leading partitions, then he don't proceed in the process?
So yeah, so the leader, the broker, which is the leader for a partition, is actually processing the workflow, it's actually doing the work. So if there is no leader, that means that if there are many brokers down and it's not working, so that's like we hope that it never happens. So so if you have 3 replicas and there is one node down, you still have 2 replicas, and one of them will be leader, and then they can still make a progress. Okay. So then it can process it in. Because yeah, that's part of the replication protocol, that we don't want to make, if some failure happens, we don't want to kind of have a wrong state, inconsistent state in the system. So we always have to look for a majority opinion there. Yeah.
So if I have 2 partitions and 3 brokers, one broker is idle.
It's idle in the sense that it's not doing the processing, but it's still replicating the state, and it's doing everything. So in an ideal cluster, every broker might be a leader for one or the other partition, because you don't. This is what I showed is not like a typical deployment. You don't deploy 3 brokers and 2 partitions, so you probably have more partitions in such a deployment. Yeah.
All right, thank you.
Just a follow-up question. In the beginning, you had 3 brokers and 2 partitions, but only one broker had both leading actions. So basically, wouldn't you have more work done if you split up the leading?
Yeah, it kind of depends on what's the capacity of your broker. So if you are like if you have like 2 cores and you put 8 partitions and 8 leaders there, of course, then you have a contention. But if you have like more 8 cores in your for your broker, and then you have your leader of 4 or 5 partitions, yeah, then it's fine, because it can still, there is enough resource to process it.
So
yeah.
So does it re-evaluate the leader during runtime, or only if it goes down?
Usually either it goes down, or let's say if there were some network issues that it cannot communicate with other brokers, and then the other brokers think that, okay, there is something wrong with this one, so we have to re-elect. Yeah, but so it's more like a dynamically it decides it.
Okay, but no load balancing, just like
right now, no. Yeah.
Isn't there still a theoretical chance that things get executed twice if something fails?
No, that's the guarantee by the Raft, that nothing goes. I mean, if something fails, there is a like consensus that who is the new leader, and then it can continue processing there.
Yeah, but if something gets executed, maybe a process system task is calling an external system and changes state in another system, and right after that, the system fails. And another leader gets elected, and he's reprocessing the event log and sees, oh, I haven't been there, it's not yet executed, or the successful execution has not yet been logged. Wouldn't it still call then the other system again?
Yeah. So in Seabee, the workflow, there is no, I mean, as a Seabee is not kind of invoking, so the job pattern that we have is like similar to the Camunda external task pattern. So the workers are actually polling Seabee. So when some job like task is activated, then it's actually written to the event log that it's activated. So and when a new leader comes, it knows that, okay, this task is already activated and some client is doing the processing, and some worker is actually executing the task. So it doesn't give the same task to some other client. So everything is, an event is like a process only if it's successfully replicated to other brokers. So you know that, okay, when a new leader comes, that okay, it knows that, okay, there's something has happened there.
Yeah, distributed transactions are always complicated.
Yeah, I mean, it's not it's not like transactions here.
Yeah,
like,
right. It's avoiding the whole thing.
Yes.
Okay.
Cool. One more. Oh, tough choice. I think you've already had your time, so I'm going to go.
Hi. Just a short question. You said the creation of a process instance will be routed to one of the partitions.
Can you repeat, please?
If you start a new instance, that will be routed to one of the partitions. And then for the full lifetime, that instance will consist in that partition.
Yeah.
For sub-processes, it's the same. If we're starting 10,000 sub-processes of that instance, then are consisting in that partition.
Yes.
Okay. That's just my question. Thank you.
Great question, thank you. Very short. Okay, I think that's us more or less done. So this track has essentially come to an end, but of course the conference is not finished. There is another final, well, 2 more sessions there in the main room. So in a few minutes, make your way there, and we'll do some Hack Day stuff. You'll see what we built over the Hack Days. So in the meantime, thank you very, very much, Deepthi, for a wonderful presentation.